I'm very excited about today's webinar topic focused on lake monitoring. Volunteers collecting lake data is one of the oldest forms of aquatic citizen science or volunteer monitoring in the United States, with programs dating back to 1970. It is fun to note that the oldest lake monitoring program internationally dates back to 1443 with Japanese monks collecting climate data on Lake Suwa. Today, lake monitoring is a great example of community lab partnerships with volunteers playing diverse roles in collecting and analyzing water quality samples. This webinar will highlight 2 lake volunteer monitoring programs, their protocols, community case stories, and examples of data use. We have 2 fantastic speakers today, Mary Skopek with the Iowa Lakeside Laboratory and Tony Thorpe with the Lakes of Missouri Volunteer Program. Today's webinar will include 40 minutes of presentations, followed by a Q&A period. And just as Candace said, as a reminder, please submit your questions using the chat function and send them to all presenters or all panelists. So today we're going to get started with Tony Thorpe. Tony Thorpe is a fantastic colleague. He has been the coordinator of the Lakes of Missouri Volunteer Program since 2001. He has a master's degree from the University of Missouri School of Natural Resources, where the Lakes of Missouri Volunteer Program resides. Tony is also on the board of directors for the Lakes of Ozarks Watershed Alliance. Tony, take it away.
All right, hello. Before I get started, I need to mention the difference between lakes and reservoirs. We're called the Lakes of Missouri Volunteer Program. However, we are monitoring reservoirs. So I'm going to slip back and forth between lakes and reservoirs, but I'm talking about these dammed up rivers in Missouri. Next, please. So I know many of you here will have a stream monitoring background. Not too many will have a lake monitoring background. So in ways in which lake monitoring differs from stream monitoring is it tends to be a more solitary experience. We have a lot of people with that sample by themselves, jet skis or canoes or kayaks. There's no group of people on the boat. A lot of times it's people in, just in a kayak. And so it's a more solitary experience by nature. And another thing, boats are expensive. So the people that are monitoring lakes are sort of selected. It's a selected portion of the population. We don't do invert monitoring, so we're primarily looking at lake chemistry. And then when we have the data, there's a lot less variability in lakes than there is in streams. Stream water quality, will be flashy depending on climate, weather, and lakes will be too, but not nearly to the degree that streams are. And so with that, we'll talk briefly about the Lakes of Missouri Volunteer Program, big picture scale. We are housed at the University of Missouri. Our monitoring for this program is designed to augment our existing in-house summertime monitoring, where we use students to do the monitoring of lakes. The neat thing about using these volunteers is that they are not confined to the classroom period. So come May, they don't have to run back to class. They can, or rather, sorry, they're not in class until May. They can monitor for the spring and the summer, and then come August, they don't have to go back to class. They can continue monitoring. So that's nice. We get a broader temporal data set with the citizen science program than we do out of our in-lab stuff. The water bodies we're looking at are small ponds. Some of them are just a few acres to big 22,000 hectare or 54,000 acre reservoirs like Lake of the Ozarks, Table Rock Lake. You may have heard about Lake of the Ozarks from a popular Netflix show. And it's a great way to involve citizen scientists, just people around the state, like many of you on the line here. Okay, next please. And so if this is designed to augment our existing monitoring program, what's the point of using volunteers at all? Why don't we just hire more staff to head out in the field and do the monitoring for us? Well, using citizen scientists has a great cost-benefit analysis. Or the cost-benefit analysis is great when using citizen scientists. Um, Not only are we getting free labor, but these volunteers, as in the picture here, Suzanne Stillwell at an Earth Day event borrowed our demonstration board and was showing school children what she was doing, sort of spreading the good word um, outside of us. We as university employees wouldn't have been at that particular event. And that sort of stuff happens all the time. Another cool thing, as you all probably know, that citizen scientists tend to be near the place they're monitoring, um, and so they're the eyes and the ears in the field. There have been many times we've been presenting data at in certain areas, and there's something we can't explain in the data, and people will just raise their hand and say, "Oh, I know what that is. That's so and so, you know, turned off a pipe, or there was a storm or something." Anyway, they again these volunteers are just not intended to replace field staff, but they augment us. So, from a cost point of view, volunteer monitoring is expensive at the outset. This is just a simple graph, the cost of the equipment um, across the number of years is a cost per sample measure. So our sampling kits are like $600, but so the first year, the cost per sample at 8 samples, it's kind of pricey. But if they keep sampling, then the cost per sample goes down very quickly. And so time invested in retention, interacting with the volunteers and keeping them happy is time well spent to keep costs down. Next, please. So the typical LMVP volunteer lives on the lake. About half of them do, and they're in some rural areas or semi-rural areas, sort of suburban, low medium density areas. A lot of them are retired, and that's especially on the bigger lakes. The property values are kind of high. Um, the barrier to entry to get on the water is kind of high. So boats are expensive. So retired people tend to have, many of them tend to have some income, and so they make up the biggest chunk of our group. Word of mouth is our biggest recruiting tool. So just the volunteers talking with each other in these lakeside communities. If somebody can't sample anymore, they talk to their friends and find somebody to take their place for them. So since 1992, that's how long we've been monitoring lakes in Missouri. We have monitored 285 sites on 125 lakes. So as you've probably figured out, we have more sites than lakes. Many of our lakes, like Lake of the Ozarks, Table Rock, we have 19 to 20 sampling sites. In 2017, we had 115 sites on 63 lakes. And so that represents about half of the lakes that we've ever monitored. We're still monitoring today. And so that speaks to our retention, which I think is pretty impressive. And so here's that Table Rock Lake. This is a Google Earth image. You can see these are the 2017 sampling sites. And you can see they're pretty well distributed across the whole lake. Interestingly, on Table Rock Lake, the water quality in this single reservoir shows the same gradient that we see statewide. So the upper arms of some of the inflowing streams, we have water quality similar to. Anyway, it runs the range of water quality in Missouri, just in this one lake. Next. And so I'm going to kind of run through the nuts and bolts of our program and how it works. And so these next few slides are we're going to follow a water sample from the field into our lab. And so, but first I want to talk about Candy and Lee. They've been monitoring. They recently hung up their Secchi disc, but they had monitored for 27 consecutive years for our program. They were there from the very first year. So hats off to them. And so the next slide would be the volunteer training. So before we begin collecting samples with our citizen scientists, we have to train them. It's about a 2-hour process, so one-on-one. with me or a colleague or sometimes a couple of us going to visit the potential volunteer and actually training them. That may be 3-4 hours of drive time, um, and then a couple 3 hours on the water. Um, so that's a big time investment. And we collect the first sample together. But what it does is establishes a relationship between us as humans and these potential volunteers. And I think that's part of what's helped keep our retention high, our turnover low. Our typical volunteer has been monitoring for about 8.5 years. Next, please. So once they've been trained, they begin their monitoring 8 times per season from late April through mid-September. Typically, they're monitoring from a boat near the dam. And as I've shown before, some reservoirs have multiple sampling sites. Next, please. So here's once they've got their sample, they're going to drive it home or boat home and process it typically in their kitchen. You see down below the photos of somebody doing a chlorophyll filter, so passing measured volumes of water through a glass fiber filter, and then the filter is what we analyze. And so on the right, that image just sort of um, shows volunteers the big picture of how to do the processing. We've got manuals that cover all this stuff in detail, but this is a nice cheat sheet for them. And then the samples are stored frozen at their house. Next, please. So once they've got the samples, after they've got about 4 in their freezer, I will jump in the car and drive around the state picking up their samples from them. And so I do this twice a year in July and October, and it is a huge time investment. It takes up at least a couple of weeks of driving each round. But what it does is it gives me the opportunity to check in with the volunteers. Um, I pop in and we chat for a moment. I get their samples. Um, some well-trained volunteers know how to bake cookies and will provide those for me, which I dearly love. But it helps with volunteer retention, being able to actually check in and chat with volunteers. Um, at least I feel that it helps with volunteer retention quite a bit. Next, please. And so once we collect all the samples from the volunteers, we bring them back into our lab where we do the analyses. And because they're lab analyses, we have nice low limits of detection, and we get some nice high-quality data. And our state regulating body, the Department of Natural Resources, actually uses the data and regards it as high quality. And next, please. So we'll get into the parameters that we're measuring. And I guess this slide is just a breeze by. There we go. Yeah. So the parameters we're measuring, we're looking at surface temperature, and I won't really talk about that. Everybody knows how surface temperature works. But we'll look at Secchi. I'll get into the detail of these later. We're starting to look at temperature and depth profiles. We look at nutrients, total nitrogen, total phosphorus, chlorophyll concentration, suspended solids, and we've started looking at algal toxins now, 2 of them since last year. Next, please. So the first one's the Secchi transparency. This is a measure of water clarity. This tool is universal across lake studies and even marine studies. But it's water quality. Water clarity is how most people see water quality. So if the water is clear, they assume that the quality is good. And so it's a simple tool that people can get in their heads, get numbers, instant feedback. Like today, the water was much clearer than it was 2 weeks ago, and by using this simple tool. And a quick shout out to Father Angelo Secchi, who celebrates his 200th birthday this year. So yeah, that's good for him. That's all right. Sorry. Something we started doing, I've mentioned these temperature depth profiles. Understanding the temperature depth profile is important for knowing how water stratifies. If you've been in a lake and jumped in and felt the colder water at the bottom, and then you come onto the surface and the water gets warm again, what you've done is you jumped below this thermocline, and in this graph, you can see temperatures on the bottom and depth is on the vertical axis on the left side, with 0 at the top. It's the surface of the lake. So imagine jumping in from the top of that graph, going down about 5 meters, so you're going to feel that cold water and come up and scream when you reach the surface again. But we're measuring this with these fishermen's tools, this fish hawk that you see in that picture. And so far, seems like they're doing a pretty good job. And so it'll help us know how deeply lakes stratify. We're also looking at nutrients, nitrogen and phosphorus, primarily in the way that they fuel algal growth. And next slide, please. And that's, we're measuring algae by looking at the chlorophyll. It's an estimate of the planktonic algae. So in stream stuff, you know algae is that green crud that kind of grows on the rocks, or the stringy stuff that hangs on tree branches and stuff. But in lakes, that tends to be floating around rather than attached to stuff. Next, please. We're also looking at suspended solids. So the way we're looking at this is looking at inorganic suspended solids, or non-volatile. It's particulate inorganic matter, and so it's a measure of soil particles in the water. And next, please. So the newest thing we're looking at, as of a couple years ago, we're looking at algal toxins, and I've got this slide in there in case people don't know about this issue. I think most people do, but we're talking about blue-green algae, cyanobacteria, that create these toxins that in the water can create problems for people. And in Toledo, resulting in the no more drinking water for a very long time, because Lake Erie had a bloom in it. Now we got problems in Florida. We had a problem here in Columbia, Missouri last month. But so just so you know, this stuff's happening everywhere, and fortunately we're measuring that in Missouri. Next, please. So this is from the CyanoHabs newsletter, and if you're not signed up, it's worth it. Give it a shot. The address is down at the bottom. And in the September, last month alone, the numbers here represent numbers of water bodies that were shut down or had health advisories or some sort of caution issued against them because of toxic algae. And so it's a widespread problem. It appears to be getting bigger. Of course, we're looking harder now, but it's a big deal. Next, please. And so fortunately, we started looking for it too. We're looking at two toxins, microcystin and cylindrospermopsin, with our volunteer program now. Primarily, it's ambient monitoring, so they're monitoring for these toxins at their same monitoring site, as opposed to targeted monitoring. So they're not looking for funky green water and sampling that. They're sampling at their standard site. We use an integrated sampler. It's about a half a meter long, and so whether the bloom, as in that funny picture at the bottom, if the bloom is on the surface or dilute throughout the water column, we're standardizing the sample collection method. Next, please. And so here's some quick look at some of the data from 2017. The 2018 samples are largely in the freezer still. But 4 micrograms per liter of microcystin, that's the EPA's recommended guideline for the limit for recreational contact. So if the microcystin concentrations are greater than 4 micrograms per liter, they recommend you don't get in the water. Based on our data, we only saw exceedances over 4 micrograms per liter in 3 different water bodies. This graph is showing a combination of our volunteer data and our statewide monitoring, our lab work. Next slide, please. Oh, okay. So we also look at quality assurance. We have a quality assurance plan, and we have our quality assurance protocol plan. Our QAP is submitted to DNR on an annual basis, and it gets approval and goes through various tiers of editing. But every year we go through that. We also annually visit some volunteers, do side-by-side monitoring. That's what these graphs on the right represent. So the MU at the x-axis on the bottom, that represents our results versus the volunteer axis. Results are on the left vertical axis. And you can see that we get nice, tight regressions between the volunteer data and the data that the samples we analyze We also provide feedback to our volunteers for our chlorophyll filters. When they filter water, they do 2 chlorophyll filters, and we compare each replicate and then report the results to the volunteer, and that's on the next slide.
2 minutes left, Tony.
Okay, yeah. And so this is what we send to our volunteers each year. On the left-hand side, you'll see each chlorophyll filter in the pair, the filter 1 and filter 2, and we assign a grade, and we give this to our volunteers as a grade card. Jim and Joan did a great job, by the way. And on the right-hand side, that pie chart, you'll see our sort of statewide results, and it shows that 90% of our volunteers' filter pairs were either excellent or good, which means they varied by less than 10% from one another. And then the other 10% varied somewhat more. But again, those are great data, and looking at our in-house results, the numbers are very similar. Next, please. So to summarize, it's a long-running program. The Lakes of Missouri Volunteer. We've been around for we're going to get ready to start our 28th year, if I'm 28th year if my math is correct. We've got quality data that our regulatory agency uses. We have experienced volunteers. They've been around in monitoring on average more than 8 years. We've got slow growth, but we've got high retention, so we don't have to work so hard at recruiting. And the next slide, please. And we haven't done this alone. The University of Missouri, that's where we're at. Started this with the Missouri Department of Natural Resources through 319 funding from the U.S. EPA. Lately, we've had some great help from the Missouri Department of Health and Senior Services, and of course, bunches of great volunteers. And the next slide is a slide of a handsome child, and I can stop talking, and I apologize for the backsides in that photo.
Thank you so much, Tony, for a great presentations. And for those of you listening in, please remember if you have questions to write them into the chat function, and please direct your questions to all panelists. Thank you so much. Now I have the pleasure of introducing Mary Skopek. Dr. Mary Skopek is also a fantastic colleague. She's the Executive Director of the Iowa Lakeside Laboratory Regent Resource Center, and she was formerly a Senior Scientist with the Iowa Department of Natural Resources, where she coordinated the beach monitoring, stream monitoring, and citizen monitoring, or Iowa Water programs. Mary is also a member of the National Water Quality Monitoring Council and National Advisory Committee on Water. Mary earned her bachelor's and master's in geography and her PhD in science at the University of Iowa. Mary, take it away.
All right. Thank you, Julie. And I'll just say I think Tony did a great job of setting us up, and I pretty much totally agree with everything that he had to say about how lake monitoring is different than stream monitoring, and then just in general how great it is when we get these volunteers collecting wonderful samples. So next slide. As Julie mentioned, I've only been with the Iowa Lakeside Laboratory for about 2 years, so I really need to acknowledge Jane Shuttleworth, who really created this program called CLAMP that we'll talk about today, and then Dennis Heimdahl, who is our state hygienic laboratory chemist, and he's done a wonderful job running samples. So these guys are instrumental and probably should be giving the presentation today, but I'll just muddle through, I guess. Next. For those of you who don't know where the Iowa Great Lakes are, because while they are well known in Iowa, they're probably not well known in the rest of the country. It's located in northwest Iowa, where most of our natural lakes are located. Next. And Lakeside is located on the shores of West Okoboji, which is a deep glacial lake, at least for our standards, surrounded by shallow glacial lakes and wetlands. And so we're in a lake-rich environment, which is really important to the economic well-being of Northwest Iowa and Iowa in general. Next. Our program is called the Cooperative Lake Monitoring Project, and it's been going on since 1999. So not quite as long as what Tony has happening, but we're excited because next. It is our 20th birthday, so we're excited to hit that 20-year mark. I think it's a really outstanding accomplishment, and hopefully we'll get to 28 as Tony has done. Next. If we take a look at the sampling then, and go ahead and hit the next one, Julie. We have 27 sites that we're sampling in these 11 different lakes, and as Tony indicated, we're trying to get good geographic distribution in these lakes. Even though the program itself is geographically isolated to Northwest Iowa, we're trying to get good spread in these different lakes and really hit them pretty hard. And so we're sampling 7 times over the year. We don't start our program until June because in May it's awfully cold. Many of the boats are not actually in the water yet. So this year we had ice on the lake until May 1st. So we get a little bit later start than Tony does, but do go through September. And so we've had over 3,700 visits over 20 years. Next. So for us, it's the longest continuously running lake monitoring program in the state of Iowa, and that's a very significant thing. Iowa was late to the water quality monitoring game, and this actually predates our DNR ambient monitoring program, including the DNR lake monitoring program. Next. And so the DNR professional monitoring, which is run collaboratively with the Iowa State University, is only 7 sites. And so there's generally 1 site per lake and only 3 times a year, concentrated in the times when students are available to collect samples. And so they are geographically more limited and temporally more limited than our monitoring. And as Tony indicated, a lot of that's because we have retired volunteers who live close to the lake, can get out there quickly. We're not having to mobilize from 300 miles or something like that to collect a sample. And again, that program is only 17 years long. So the amount of data coming out of this CLAMP program far exceeds what we can do with the professional monitoring. Next. As Tony indicated, quality assurance, quality control is a big part of this. So everyone goes through an annual refresher workshop or an initial training. We did have a YouTube channel developed for our volunteers so that they can go on and look at these how-to videos, just again to provide some refresher on how to do the sampling and the monitoring. So we don't have a lot of people on our subscribing to our channel, so if you'd like to join, that would be wonderful. The one thing that we have going for us, unlike the previous program that I was in, IOWater, is that all the samples are analyzed by the State Hygienic Laboratory, which is part of the University of Iowa. And we are quite fortunate because we have a branch of the State Hygienic Laboratory co-located with Lakeside. And so we have this phenomenal experience where volunteers can bring their samples directly to the lab and work on getting them analyzed. As Tony did, we're pairing new volunteers with experienced volunteers so that we don't send anybody out there who doesn't really know the protocol well. They're working with somebody who does know that protocol. One thing that we've branched into this year, as Tony indicated, the lack of boats can be an issue. And so we've worked with local fishing clubs to have people that maybe aren't as interested in sampling or the monitoring, but have a boat and could get volunteers who are interested in sampling out on the water. So it's a nice partnership with people who care about the lakes to get that access to the water that they need. And then we're working to get the field meters calibrated before each site visit. The field measurements are very similar to what Tony talked about. So water clarity, dissolved oxygen, temperature. We aren't with the CLAMP program doing profiles, although we do have a Gleon buoy in one of the lakes that we can compare our data to the Gleon buoy that's collecting 15-minute samples all the way to about 80 feet in depth. Next. So those were field measurements. In terms of laboratory analysis, we're looking primarily at nutrients. So looking at nitrate, nitrite, ammonia, organic nitrogen, and dissolved and organic phosphorus. And then, as Tony mentioned, we're also looking at algae abundance, looking at chlorophyll A. And we have the volunteers bring those samples back to the lab. We have the CLAMP headquarters here at Lakeside, and the volunteers are actually doing the filtration for chlorophyll and then can bring those samples directly over to the laboratory for analysis. As with Missouri, we are adding microcystin into our monitoring. So we actually started collecting samples in 2017 through a grant that we wrote to a local foundation that started to analyze samples in 2018 for microcystin. And I think this is significant because, again, the DNR monitoring program is looking at microcystin only during the recreational season, which is Memorial Day through Labor Day. However, some of our most significant blooms are occurring after Labor Day in September and October, and it leaves a big gap in the information about when we might be having these big blooms. People are still recreating in the water well after Labor Day, and so we're able to really augment what the DNR program does by adding microcystin to our program. The data are all available on this CLAMP 1909 blog spot. Essentially, if you go to this Google map, if you click on one of the dots, which is color-coded by the current data in terms of the trophic status of those lakes, you click on a dot, it brings up the site name and number, and then you can actually click on the data itself and bring up essentially what's a Google Doc, Google spreadsheet, and you can see all the data since 1999 and actually just grab that, copy and paste it, and bring it into a different spreadsheet and manipulate it and analyze it. So we're excited that all that data is available on the website and is used by a variety of agencies around the state. Next. So how are we using the information gathered? Perhaps the biggest issue, since now we have 20 years of data, is to really track changes through time. So we want to know, are we doing things that are improving the lakes? Are the lakes degrading? This is, as I said, a very important economic driver to Northwest Iowa. And there's been a lot of investment in lake restoration. There's been restoration of wetlands and prairies. And so one of the things we want to know is, has that investment paid off? Are the lakes getting better as a result of that? The data are also being used to develop watershed plans, and so we see a lot of efforts going into planning to renovate a lake, and that the CLAMP data is always the first thing they grab because, again, it tends to be more information both temporally and spatially in those lakes, and so it's been really helpful for those watershed plans. And then, again, I think, as you all know, it's really important to engage that lake community, and I think the information that they're getting, the way that they see how the lakes are changing, really energizes that lake community to continue to protect and get involved. So that's a big thing. The last piece is, of course, K-12 education. Lakeside had about 4,000 school children, K-12 kids, come through our doors last year, and we're always looking for ways to engage both the teachers who want to do authentic inquiry-based education and the students. And so, again, having that data online really makes it accessible for those students to ask questions and do some really interesting programs and projects. Next. So I just wanted to give a little example. One of the things that we had happen up here, unfortunately, was the introduction of zebra mussels. And they were first really detected in the Okobojies in about 2015. And what we've heard is, or what I hear is, well, you know, boy, the lakes are sure clear in 2018, but it's because of the zebra mussels. And because we have this really nice long data set, we can actually dive into that a little bit. So next. So basically, this is just showing you, and I know it's a lot of data, but kind of bear with me. On the top, we have the Secchi depth in meters. So the longer the bar, the clearer the water is. And on the bottom is our total phosphorus numbers. And the red line that goes from top to bottom is where about zebra mussels came in. And then the red line in the Secchi, just the horizontal line, is our goal for lakes in the state of Iowa. And so this is East Okoboji, which is one of the shallow glacial lakes that we have. Its depth is really only probably about 20 feet or so. And one of the things that we've been able to do is when we look at this graph, we can say, you know, the total phosphorus numbers have really come down over the last 20 years. We're seeing kind of a slow decrease in those phosphorus numbers, probably because of the things that are being done in the watershed to reduce the amount of sediment and phosphorus running into the lakes. And so that decrease has been happening for a long time, really for the last decade, I'd say. And the water clarity has been slowly improving as well. And so I would argue that the increase in water clarity and the record water clarity that we saw in 2017 was maybe somewhat zebra mussels, but really being more driven by the fact that those phosphorus levels are getting better, and that people are quick to jump on, the thing that they read in the paper, which is the zebra mussel, but we can talk about, no, it's really the investment we've made in the watershed as well, and that's a really significant thing to see that improvement. And what was unheard of in that record clarity that we saw in 2017 was the Secchi disk actually hit the bottom of the lake, and nobody living can remember that happening before with this lake, which has generally been very turbid. A lot of algae was very, very, very clear, and that was really exciting for everybody to see that level of water clarity, which again shows the value of the investment that the community had made in watershed protection. Next. All right, all right, just a couple of other examples. And again, rather than showing you each individual data point, I'm just showing you that kind of clumped together, looking at the median Secchi disk depth and chlorophyll and phosphorus. And again, site number 55 is at the very tippy top of East Okoboji. But again, those phosphorus levels have really dramatically decreased over the years to the point where they're almost to the point of achieving the DNR standard, which is really phenomenal. Next. And again, Big Spirit, again, we're seeing some improvement, not quite to the same level. And so we can start to talk to people about, we really need to try and invest in Big Spirit so that we can get those chlorophyll numbers down even further and those phosphorus levels down even further. One of the exciting things is at the top of that lake, the very northern shore, Natural Heritage Foundation in Iowa has purchased a bunch of property up there, which is going to be converted from row crop to natural prairies, wetlands, and some other kind of native areas. And we'll have the opportunity with the sites that are being sampled right now to track how that improvement in land is improving the lake. And so we've got this phenomenal baseline data set that's really going to inform us. And so again, the DNR site would be down there at BSL 54.4, but we have samples up at BSL 54.1, which are really going to be helpful in evaluating the progress made because of this generous donation. Next. Oh, and again, one of the things I talked about is so not only tracking big changes over time, but events. And so 2018 was very significant for the Okobojis. We had tremendous flooding, including 2 7-inch rainstorms that occurred in about an hour and a half. And so we saw very high water levels and, obviously a lot of sediment moving into the lake, and we're able to evaluate the impact of these big rainstorms on the lake. Next. Including things like big time shore collapse and again, being able to say, well, what was the impact of these big rainfall events, shoreline collapse? What can we do to, again, encourage people to do things that are going to protect those landscapes? So how do we get maybe some different vegetation growing along the shoreline to keep that sediment out? But our data, I think, are really going to be able to help us understand the impact of these big flood events on the lakes overall. Next. And then again, just to kind of highlight that, so if you look at, for example, our 20-year averages in those red lines versus 2018, you can see that, our average Secchi on some of the lakes, so for example, East Okoboji, which is EOL, was about the 20-year average, but many of the lakes were lower than the 20-year average. And again, I think as a result of those big events that we saw this year, so we can kind of tease out the impact of a really big flood year about how it's impacting the lakes overall. Next. I think I'm about done. Is there another slide? All right. I'm done. Thank you.